So remember that mental image of the ocean we talked about last time?
Oh yeah, the huge walls of water rolling in.
Exactly. Energy moving through the water, surfers catching a ride. Well, right now, you're doing the exact same thing. You are surfing invisible waves.
Right. Only instead of water, we're swimming in a sea of vibrating air molecules. But the physics are actually, well, they're remarkably similar.
Which is wild to think about. So, our mission today is to make the invisible visible.
Learn it fast, learn it fun. 711.
Don't forget to grab your free PDF resource, link in the description below.
Imagine if we could just freeze a sound wave right here in the room. It would look just like that ocean swell you mentioned.
You have the high points, which we call the crests, and the low points, the trough.
Exactly. But since we're talking about air, think of that crest as a high-pressure zone. It's a bunch of air molecules squeezed super tightly together, and the trough is where they spread back out.
And that brings us to volume. Because why does a jet engine feel so completely different than a whisper? It's not just a dial you turn up in the air.
No, not at all. It's physical violence against the air, and that is amplitude. It's the height of the wave, or more accurately, the intensity of that pressure squeeze. A jet engine creates a massive wave height. It is physically punching your eardrum with air pressure. Whereas a songbird is barely making a ripple. Low amplitude, very gentle pressure.
So amplitude is loudness. But then you have pitch, the difference between a deep bass drum and a squeaky whistle.
And that's purely about the length of the wave. Wavelength, literally the distance from one crest to the next.
I love the dog whistle example for this. The whistle creates waves that are packed so tight, super short wavelength that our human ears can't even process the clicks. But a dog's ears absolutely can.
Compare that to a flute. The flute creates longer, lazier waves. The crests are spaced further apart, which our brains translate as a lower or a more musical note.
Okay, so squished waves equal high pitch. Stretched waves equal low pitch. But here is where it gets chaotic. Sound waves don't just travel in perfect straight lines forever. They crash into each other.
They do. This is interaction. Sometimes waves team up, and sometimes they actually destroy each other.
When they team up, that's harmony, like instruments in an orchestra or a band.
We call it constructive interference. When a wave's high point meets another wave's high point, they combine to make a mega wave. They boost each other. That's why a chord sounds so much richer than just a single note playing.
But the opposite is way wilder to me. If a high point meets a low point, destructive interference. +1 meets -1, and they just cancel out.
Which is exactly how noise-canceling headphones work. They aren't just blocking sound like earplugs. They are actively fighting it.
The microphone hears the airplane engine, and the headphone fires an anti-wave, an inverted sound wave, to mathematically delete the noise before it hits your ear.
It's literally using physics to create silence.
Incredible! Wow! Now, we've talked about waves hitting each other, but what happens when the actual thing making the sound is moving?
Yeah, the Doppler effect.
The truck is coming down the street at you, the siren screams super high, and then as it passes, it drops low. But the siren itself isn't changing.
The motion of the truck is mangling the waves. As the truck drives toward you, it's chasing the sound it just made, squishing those waves together.
And squished waves mean a higher pitch.
Exactly. But the second it passes you, it's running away from the sound. It's dragging the waves out, stretching the wavelength.
Stretched waves mean a lower pitch. That's the Doppler effect, named after Christian Doppler, who discovered that sound waves change pitch if they are moving toward or away from you.
This isn't just about traffic, which is the coolest part. Scientists use this effect to track how fast storms are moving using the Doppler radar. And astronomers use it to find things we can't even see.
It is incredible that the exact same rule governing a street siren allows us to map the galaxy.
So sound is just invisible physics, which means your ears can hear physics. Volume is the height of the wave, pitch is the length of the wave.
Next time you hear a siren, you're basically hearing science in real life.
711, what's your emergency? Why? 711, what? Yeah! It's 711, yeah, we're on the line. Science help is here, and we're right on time. Got a question?
Call it out.
Let's begin, we learn it super easy. Come on, jump in. 711.